So now we have the expression for n bar and e bar. Now we will define a term known as Q potential. So Q potential is defined as Q is equal to Ln summation over Rs exponential minus alpha nr minus beta es. So this is the way we simplify this one, right? This is the, so Q potential is equal to Ln of sum over Rs exponential alpha nr minus beta es. This was originally proposed by Kramers, and in his kind of discussion, he assumes that Q is a function of alpha, beta, and es. So this is his assumption. That Q is a function of alpha, beta, and es. So therefore, I can always try to differentiate or express Q in terms of all those terms as a differential. So if I take differential of Q, dQ is equal to dou Q by dou alpha into d alpha plus dou Q by dou beta into d beta plus dou Q by dou E into ds, right? So now let me put this one, this as equation 1, this as equation 2, right? Now our task is to do this, to find out these terms separately, dou Q by dou alpha, dou Q by dou beta, and dou Q by dou E. So what will be dou Q by dou alpha? Dou Q by dou alpha is equal to dou by dou alpha of Ln sum over Rs e raised to minus alpha nr minus beta es, right? Which can be written as equal to, if I take that, I can write 1 by sum over Rs e raised to minus alpha nr minus beta es. You can always try to do it yourself. Let me, so this is Ln, so that's why I'm doing like this, sum over Rs e raised to minus alpha nr minus beta es into minus nr, right? So this is the expression for dou Q by dou alpha, and I can always attempt to simplify this. So this will be nr, so this will be minus sum over Rs nr into e raised to minus alpha nr minus beta es divided by summation over r e raised to minus alpha nr minus beta es. So that is the expression which we are having, right? Which I can write it as minus of the average value, the expectation value of the n, which is minus n bar, right? So this is the term. I have the minus here, so you can do it yourself. So this actually gives me the expectation value of the n. N is the total number of particles, right? So that is it, which is minus n bar. And similarly, you can try to find out the value of dou Q by dou beta. That will come out to be minus sum over Rs es into e raised to minus alpha, minus alpha nr minus beta es divided by sum over rs e raised to minus alpha nr minus beta es, which is again I will get the expectation value of the energy of the system, which I can write it as minus E bar. So that is dou Q by dou alpha, and dou Q by dou E is equal to minus of summation over Rs minus beta into e raised to minus alpha nr minus beta es divided by sum over rs e raised to minus alpha nr minus beta es, right? So that's it. Now I can substitute, say this is 3, 4, 5. So I can now plan to substitute 3, 4 and 5 in equation 2, right? So on substitution I will get dq is equal to minus n bar d alpha minus e bar d beta plus the last term, right? Minus summation over rs beta e raised to minus alpha nr minus beta es divided by summation over rs e raised to minus alpha nr minus beta es. This is what I will get, which is equal to minus so this is what, and this is des. I can always plan to cancel this out, right? These two expressions, since beta is a constant, I can take this out. In the other case, that was not the case. nr is not a constant. That was also a dependent, right? So since beta is a constant, I can always go ahead and take it outside. So these two terms will get cancelled out. So I can express it as minus n bar d alpha minus e bar d beta minus e bar d beta plus beta, minus beta des, right? That, right? So that is it. So and then I can take the minus outside. So minus of n bar d alpha plus e bar d beta plus beta des. So that is it. Extending that, okay, so I can always write d of q plus alpha n bar plus beta e bar. I just let's see what is the d of q plus alpha n bar plus beta e bar. This is equal to dq plus alpha alpha dn bar plus d alpha n bar plus beta de plus d beta E bar, right? So what I did, I just substituted that and I got this expression. So say this expression is 6. Now what I took is that I took another set of terms and I'm writing down its differential term, d of q plus alpha n bar plus beta e bar. So this I can always expand this expression in this form, right? Now I can see some kind of similarity in the two expressions. I have already found out the answer for dq, right? So let me substitute this into that dq term, into the term dq in this expression. Say let's put 7. In the equation 7, if I take dq, I substitute this equation 6 into here. So then what will I get? So that is equal to n bar d alpha plus e bar d beta plus beta des plus alpha dn bar plus d alpha n bar plus beta d bar plus d beta e bar, which I can see the terms in this equation, which I can always cancel out, right? So that these two, the n bar d alpha, e bar d beta. Sorry, there's a minus here, right? There's a minus here. So I can cancel these two terms, and I can finally write it as minus beta des plus alpha dn bar plus beta d bar, right? So this is equal to this term. Okay. Now let me put this as equation 8. And from the first law of thermodynamics, I know that dq is equal to d plus pdv, let me write it as dw, minus mu dn. So this is the first law of thermodynamics. Right. So let this be equation 9. Now what? Let's multiply this equation 9 by beta. So what will I get? Beta into dq is equal to beta d bar d plus beta dw minus mu beta dn bar. Mu into beta. What is mu into beta? Actually, mu by kt, I know that mu by kt is equal to alpha. That means minus mu beta is equal to alpha. So I can substitute that over there and write it as beta d plus beta dw plus alpha dn bar is equal to beta dq, right? Okay, so now let's try to simplify this